It's working. Yes. All right. We're looking at 2.4.3, and we're actually going to use the problems from the iMath document for classwork and homework. Okay. I think we should get through all of it in class. We'll see. So firstwise. I was thinking of Pennywise clown. That doesn't work. All right. Piecewise. All this is talking about is we're breaking the domain into different separate functions, different segments. Okay. So it's basically we're going to be making a graph with pieces of other functions kind of woven together. Okay. So, and it always has to do with breaking up the domain. We're talking about breaking up the domain along our x-axis here. So, bonus. Who can name what function this looks like? It's only part of it. We've seen them before.
A parabola.
A parabola. So if this parabola wasn't a piecewise function, right, it would continue off in this direction forever and towards infinity as well for our y values. But what we've done with piecewise functions, we decided, no, we're going to restrict the window we're looking through. We're going to restrict the window. Okay. So instead of the x values, the domain, our x values being positive and negative infinity, where we can see the whole graph, or at least see where it goes, all we're saying is we're going to restrict the parabola to this interval. Oh, just figure this. These are x's. So the parabola is restricted to its 0 is less than or equal to x is less than 2. So also we need to pay attention that when we have less than or equal, greater than or equal, we're doing closed circle as far as our line segments go. Likewise, if I have just less than or just equal, or greater than, then I'm doing open circle. The reason being is because if it's just less than or if it's just greater than, it does not include that actual point. So do we remember this one from when we did line segments before? With the step function, we did this yesterday, so this just kind of builds off this. Let's look at the domain for this segment right here. 0 is less than or equal to x, so that's why I put a closed circle right here. The other side of the interval is x is less than 2, so at 2, I make the function go to that domain restriction, and I leave an open dot because it's just less than. Okay. So basically we're just cropping. We're cutting and cropping along our x-axis. How about right here? What kind of function is this? It's just a line. We could see that it probably goes down. Maybe it crosses down here at like a half. So this would be something that you're going to be given these functions. But looking at this, we have 2 is less than or equal to x is less than 4. So because it's less than or equal to, I put the closed dot. On this side of the restriction, at 4, I put an open dot because it's just less than. Okay. So you see how we're going to cut these up. Now I wanted to give you another example of how to think about this. Okay. Think of cropping photos. Have you ever taken a picture with a friend? You know, maybe this is your little cousin, and somebody does a little photo bomb. They run in. They're like, "Hi." Okay. What are we going to do to that guy? We don't want him in the picture. You guys know how to. You guys are really good, I'm sure, at cropping pictures. Oh, yeah. Right. Oh, yeah. So that's why I want to relate it this way. Okay. Piecewise functions are just cropping your photo to include what you want to look at, to include the domain you're given, or what you want to kind of focus on. Okay. So this guy photobombed your photo. Go ahead and, with your neighbor, go ahead and tell me, or decide on your own for the 20 seconds here, what is going to be my restricted domain to just get the photo of me and my nephew. So we're going to write the domain just as we had up here as an inequality.
0 is less than or equal to, no, wouldn't it be 4 is less than or equal to 4? No, just be, which is less than. So it's 0.
All right.
Is greater than, no, 0 is less than or equal to x, which is less than or equal to 4. That's what I just said. No, you said
all right. Let's bring it back. So we want to crop this guy out. Where do we want to put our restricted domain? Where do we want to define this?
Less than or equal to 4.
Less than or equal to 4.
Oh my.
How about the lower limit of that? The lower restriction.
Wait.
So if you said less or equal to 4, you know, this is the photo, but that defines everything to the left. Everything less than. So somebody give me the domain that's set up with a lower limit and an upper limit, or a lower restriction, upper restriction. Right? No?
0.
How about this? Yeah, I'm interested between 0 and 4. So I'm going to write this. 0 is less than or equal to x is less than or equal to 4.
What did I tell you? Oh.
Did you get it?
No.
What was missing with that? Did folks just say less than or equal to 4? Okay. Remember, we have to have the restriction that's the lower and the restriction that's the upper. Otherwise, really, this is defining a photo that it doesn't go this far, but it would be saying everything to the left here is included. All right, so we're going to crop it right here. We're going to end up with a nice photo, cropped out that guy that just says photobombing us. All right, so we're going to use Desmos to do a few piecewise functions. Okay, I can't record it. Maybe I can. Let's see. All right, I just want to show you one really cool thing here. Not. Whoa, watch this. All right, back to this. So take a look at this. We go to Desmos. We're going to go to the calculator, but I want to point out one thing that is really interesting here. Yeah, that's fine. So if you're at Desmos, scroll down a little bit, and you see all these creative art aspects. Now watch this. Somebody drew, let's do this one. They did a violin using Desmos and had all these equations with the domain restrictions and range restrictions. See? So this was x is equal to negative 11.68. That's just a straight line at x is, or that's a straight line at x is negative 11.68 right here, right? And they gave a restriction. They're using the range because they only wanted this line to be that wide. Right? So what they did was they added all these formulas to create their shape, but they didn't do it from scratch. And I'm going to show you how you can do this using parent functions. So basically, they're going to set up the function. Remember, we had a times the absolute value of x minus h plus k. They set that up, and then they use sliders to move it around and manipulate it. And then they chop it. So I'm going to actually, next week or after Thanksgiving, give you an assignment like this that'll be not as difficult as this, but it'll be, look, there's SpongeBob. Yeah, so they did SpongeBob right here, and we can look and see that. Look at all the equations it used, right? So they use circles. Where is he? Where is it? There it is. So what circles what are involved here? Look, they have some ellipses, they have some circles, they have, this is probably like a parabola between, negative 2.7 and 3. They have the teeth, which are just lines.
Where are those things moving on the left?
Oh, okay. So these things on the left, you can have them function plane or not. So what is moving when they do this? Let's see, is anything changing?
The eyes.
The eyes?
No.
I can't see anything moving. So
Maybe if you let it go. Let
both of them play? Is anything moving?
I don't think anything's moving.
Okay, maybe it's really small. But anyway, we can also have things move and function like that. But we're not going to get that far along because that might seem really complicated. We're going to go ahead and did it move? Oh, there it is. Look at the eyes.
Oh.
So basically what they did,
You see, it was the eyes.
it was the eyes on my right.
Yeah, I see the change now. I was like, it has to be the eyes.
So what this is doing, it's a circle and it's changing the P and S values, or actually that's an ellipse. It's an ellipse. So it's changing, shrinking and growing that S and Q values repeatedly. Okay. So we haven't learned conic sections. All these ellipses and actually circles and parabolas are conic sections. I think we get to that at the end of the year. But we do know enough shapes. We know parabolas. We know absolute values. We know lines. Right? What else do we know? We know step. Right? Anything else? That's it. So from those three shapes, we could cut it up and make a shape, make a photo out of it. Okay. So after the break, we're going to play around with that a little bit. Might be a kind of a poster project. But we're getting ahead of ourselves. I need everybody to go ahead and go right to a new blank graph. Or if you just got into Desmos, you're just selecting start graphing now. So let's see, everybody is all logged in, good to go there. All right, let's try to do one here just for the video. So I need everybody to follow along with me on this. Let's go ahead and input into the equation right here. So this is real important. This is how we get the sliders up. So right here in the function box, we're going to put in y is equal to. You could type some of this. You can also use what's below. Y is equal to a. And then right here, you see the absolute value symbol here? We're going to click that and put x minus h. And then you see how you have to click on the outside of that absolute value to get outside of it. So we're going to click over with our, so we're outside of it, and then we're going to go plus k. Once you get all of those in there, watch. I'm going to add all. I'm going to add all, and now we have all these sliders. So watch this. We learned this already. Our a value with absolute value, right? When do we have a bad robot with absolute value? A is negative. Good robot when a is positive. So watch this. I'm going to play this and watch what happens with my happy sad. Okay, it's positive, 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 negative, 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 positive, right? All I'm doing is having my a value right here, my a value. It's sliding back and forth to show me how it goes from being up to down. I know, you found that out. So watch this one. How about when we make H play? When we make H play, what happens?
All play goes in a circle.
If all of them play, they do go in a circle.
Yeah.
All right, but how about this? H.
It goes across the.
When H is plane, we are moving between.
The x-axis.
Right, the critical point, the vertex is moving along the domain, the x to y. All right, how about this? The k. K moves it up and down. So after the break, or actually after Thanksgiving break, we're going to get into transforming functions like this. But I want you to go ahead and with this, go ahead and first put it at. Let's stop them. And let's put a at 1. Go ahead and bring a to 1. A is 1. H we're going to put at 0. It's kind of hard. There it is. K we're going to actually put at 0 as well. Where does that end up? So I want to kind of give you this idea. The thing we just graphed. What we have on the graph right now is a robot. What we have on the graph right now is y is equal to the absolute value of x. Does everybody agree with that? Look at what's missing. A is 1, right? The 1 value out here we don't write, but there's a 1 right here. H is 0, so there's nothing on the inside of the absolute value. K is 0, so there's no k value. So you see, this is our parent organization. No. This is our parent function. Parent organization is a fiscal sponsor of a nonprofit entity. I used to be one. I know. All right, here we go. So one other thing we can add are domains. Now watch this. At the top of my function up here, I'm going to put a space. I'm going to go down to my ABC, and I'm going to choose this bracket. Now watch this. I'm going to put in here, let's see, -1 is less than x is less than 2. Look what I have. What did I just do to that function?
Verify.
Oh, it's still playing. Yeah. All right, so looking at this, we just put a domain restriction on this function. Watch what I do this. Watch when I put in, instead of -1, -3. What happens? Now the window, my cropping of my photo, has been moved to a very specific restriction. You agree with that? Okay. So with this, if you need to define less than or less than or equal to, you can go right into our ABC, and there it is right there. Okay. I don't know. Let's zoom in and see if Desmos actually gives us an open or closed circle. And they don't give us either. So when we're transferring this onto our graph paper, I'd have to look and see, okay, it's x is less than 2. So right here, at this end, it would be an open dot. Right? Over here on this end, it would be, because it's just less than or equal to, closed dot. Okay? So we can play around with this quite a bit. We're going to try to do a function right now. But I wanted to show you how to do the slider like this. Okay? Once you have the parent function, you can put any values for a. And watch this. This is a good one too. Watch this. Ooh. Watch. No. That is. What happens when we do all?
It's just like weird.
It just gets out of here. It's like.
All right. Let's just see.
What?
I have fun with this. You don't have to.
I know it's gone.
So you see, you can make it a. I was trying to make it kind of go like a wave. You can't do it. All right. So for today's class, I need to stop the video. So maybe we encourage people to subscribe. Maybe we whisper it. Subscribe, whisper on 3. 1, 2, 3.